Good morning, gentlemen. Welcome to our last week of HBL, hopefully. I hope you guys will rest well at home this week, stay at home, stay safe, and also learn your content well so that you'll be ready for the next chapter next week. Okay, so let's go. We're looking at chapter 12 of your notes, and we're going to start with angle of elevation and depression. So there are blanks for you to fill up, and this is just a quick recap of angles of elevation and depression that you've covered previously in one of the chapters. Okay, so what is the angle of elevation and what is the angle of depression? Now let's say you are standing over here. Okay, you're standing over here and you're looking at the top of the building T. Okay, the angle between the horizontal, that means the horizontal is EH in this case, the angle between the horizontal and the line of sight, this is the line of sight ET. Okay, the angle between the line of sight and the horizontal, this is known as the angle of elevation. That means angle TEH is known as the angle of elevation. Please fill up your notes. Okay, so as you can see, because this is the angle made with the horizontal, it forms a nice right angle triangle, and hence we can use Tuang Kaso, we can use Pythagoras theorem and other stuff to find the angle, find the height, etc. Okay, what about angle of depression? Let's say you are looking now at the bottom of the building. Okay, so this is where you're standing, same thing, but now you're looking at the bottom of the building B. Okay, once again, the angle between the horizontal EH and the line of sight EB. Okay, this is the line of sight now. The angle between the horizontal and the line of sight is known as the angle of depression. Okay, so if you're looking up, it's angle of elevation. If you're looking down, it's angle of depression. Okay, so angle of depression in this case is BEH. Fill up your notes, angle of depression. Okay, so let's look at example 1 to see how we can solve certain problems using this angle of elevation and depression. Okay, let's say there's a point X, and the question says the angle of elevation of the top of a hill H from a point X, which is 5 kilometers away from the foot of the hill F, is 12 degrees. Find the height of the hill in meters. Okay, so they want this height of the hill, which is FH, in meters. So take note of the units. Over here, XF is 5 kilometers. Angle of elevation here is 12 degrees, because remember, angle of elevation is between the horizontal and the line of sight. Okay, so it's 12 degrees, but they want the height of the hill in meters. So as you can see, this forms a nice right angle triangle. We can immediately say, oh, tangent 12 is equals to opposite over adjacent, which is HF over 5. So we write down tangent 12 equals to HF over 5. Then we solve for HF, which is 5 times tangent 12. Press calculator. Answer is 1.06 km. Okay, but we don't stop there. This is in 3SF, right? But it's in kilometers. We need to still find the height of the hill in meters. In meters, it will simply be 1060 meters to 3SF. Okay, so write your units, write the bracket 3SF, and you're done. Okay, next question. A lighthouse TL has a height of 50 meters. Angles of elevation of the top of the lighthouse T from boat A and boat B are 48 degrees and 38 degrees respectively. Find the distance between boats A and B. So take note, now they're still talking about angle of elevation, although you see that the lines are going down, right? So why is it so? Because they're saying that angle of elevation of the top of the lighthouse from boat A and boat B are these two angles. That means there's a person on boat A, for example, and looking up, he's looking up at the top of the building, okay, at top of the lighthouse, which is T over here, right? So this is the line of sight from the boat. Okay, so what is the angle? Remember, the angle is always between the horizontal and the line of sight for angle of elevation. So in this case, it's the angle TAL, which is 48 degrees. And the same thing for boat B, angle TBL is 38 degrees. So once you know the position of the two angles, you already know that the height of the lighthouse is 50 meters, and now your idea is to find the distance between the two boats, okay, which is basically the length AB. So what can you do? You can see that there are two right angle triangles formed, TLA and TLB, okay. These are the two right angle triangles formed. You know the opposite side, 50, you know the angle, and you just need to find LA and LB so that you can find the difference and find side AB. Okay, so it's a simple matter of knowing where your angles are, whether to use tangent, cosine, or sine, and then you find the appropriate lengths. So obviously we will just use tangent because tangent 48 will be opposite over adjacent, and we can find LA immediately. Okay, so that's what we are doing here. Tangent 48 is equals to opposite over LA. Find LA, press calculator. You will get 50 divided by tangent 48, which is 45.020. Okay, you can either write the 5 as F, or you can just keep it as a fraction like that also can. And then we do the same for LB. So opposite over adjacent will give you LB, right? Which is basically tangent 38 is equal to opposite over LB. So now I'm looking at the bigger right angle triangle over here. Tangent 38 is equals to 50 over LB. So LB is equals to 50 divided by tangent 38. So the difference is basically going to give you the distance between A and B. Okay, so you take LB minus away LA because LB is the longer length, right? So length of LB minus away length of LA, you will get the distance between A and B, which is 19.0 meters to 3SF. Don't forget your units and your bracket 3SF. Okay, example 3. Now we're looking at this question. In the diagram, BC is a building of height 30 meters. From the top of the building at point C, the angle of depression to a man at point A on the ground is 35 degrees. So remember, the man is on the ground. He's just a point, okay? He's like point A. He's just on the ground, flat on the ground. And angle of depression from the top of the building C, which is over here, is 35 degrees. So we will draw a horizontal at C over here, right? We will draw a horizontal like that, CD, and the line of sight is over here, CA. Angle of depression is the angle between the horizontal and the line of sight, which is over here. So 35 degrees over here. Okay, and because these two are horizontal, right? Both CD and AB are horizontal. They are parallel lines, and hence this 35 degrees is the same as this 35 degree over here, which is CAX. Okay, because of alternate angles. So this is how you find the angle of depression here, and ensure that you also know that this is 35 degrees. Okay, question already told you, to make it even more obvious, right? Question told you that line CD is parallel to the ground. Indicate the angle of depression of the man at A from C on the diagram. So this is how you indicate. You write down 35 degree here, and you say angle of depression of the man at A from C. Okay, part B, find the distance BA. BA is over here. So you're looking at this big right angle triangle here, right? BAC. And you know that BC is 30 meters because height of the building is 30 meters. Angle here is 35. So tangent 35 equals to opposite over BA. And then you solve for BA. 30 over BA equals to tangent 35. Therefore, BA equals to 30 divided by tangent 35. Answer is 42.844. Okay, so to 3SF it's 42.8. Okay, last part. There's another man standing at point X. His angle of elevation to point C is 55 degrees. Calculate the distance between the two men. Okay, so there's a man at point X. Now this time they're looking at angle of elevation, but it's the same thing between the horizontal and the line of sight, right? So this angle is 55 degrees. So how do you find what is the distance between X and A? That's what the question is asking, right? So you look at the small right angle triangle here. Tangent 55 is equals to opposite over adjacent to find BX. because part B we already found BA, right? So if we know BX, then we can subtract away and find XA. So write down tangent 55 is equals to 30 over BX. Therefore, BX is 30 over tangent 55. Hence, you find the distance between the two men by taking 30 over tangent 35, which is BA. And you minus away 30 over tangent 55, which is BX. Okay, and immediately you will get 21.8 meters to 3SF. Okay, you may once again choose to use the 5SF value from just now, or if you want to be even more accurate, you just use the fraction here, 30 over tangent 35 in your working here, and you will never go wrong. So answer is 21.8 meters to 3SF. Very good. This is simple because half the time or almost all the questions you're just using tangent to find the sides. So it's super easy. Okay, for your homework, can you all please do the following questions from exercise 7A on page 217 of your Sec 3 textbook. Okay, so we are looking at the Sec 3 textbook. For those who don't have, I'll send a picture. So I want you to do question 9, question 12, and question 13. Okay, very easy. Just 3 questions and upload on Google Classroom. That's it. Okay,